Okay, now we've got a bunch of data that's describing characteristics of our plots. We've got basal area, biomass, and size classes. It's time to start categorizing or summarizing this long list of data points in some way where we can start to make sense of it. A long list of data points doesn't say very much on its own. It's up to us to summarize these in terms of their central tendencies, that is the average, um, and it's the variance of the data sets. So let's do that. One of my, I think the most efficient ways to do this is to use a little, sometimes frustrating, but also very helpful macro called a pivot table. That's, again, I don't use these very much, but they are easy to work with at this point with Excel. I should mention that Excel is based on a language called Visual Basic, and there's a command line language to it, and you can see that when you write in an equation using the equal sign in Excel. But Visual Basic is also, it's just designed, it's a language that's designed to work in this kind of graphical user interface. And that's what we're going to use. The quirks with Excel sometimes emerge because of the way that the thing is programmed or how it relates to the commands that and the VB language. So just user beware. But what I'm going to do here is I'm going to insert this dialog. It's really helpful. I mean, it will really save you a lot of time. I always want it on an existing worksheet. I always put these next to the data that I'm working with. And you have to select the data. Excel kind of guessed that I was going to summarize this table, so it already selected it, and I just want to make sure that it's got everything, and it does. Okay, so once you hit OK here, you get this dialog, and this is where you start to have some power to do things really efficiently. You can just play it with, it's really nice. You can summarize your data in different ways. So I put basal area down here. It assumed that I want to sum it. That's nice. It's summed the overall basal area for the entire data set. And if you know how many plots are in here and how much total area that has been surveyed, and at this point I think it's 19, then you just have to divide this by 1.9 and you'll get basal area per hectare for all of our Polycanyon plots. But that's not what we tend to usually have to do. What we want to know is how it's broken down by plot. Oh, excuse me. Oh yeah, that's missing one plot. It's missing plot 17. I saw the 20 and I was like, oh cool, everything's here. But anyway, so this is the basal area for each individual plot. Now keep in mind, that's the sum of everything that was measured in that plot. This plot 2 has really high basal area, like so much to the point that I kind of question whether it's right, because you're going to multiply that by 20 to get to per hectare, and you can end up with something that's really a lot of biomass. Okay, we'll let that go for now. We can also do the same with biomass, and this is nice. And you know, you can do things like this. You can select the data. You can I always like these, you know, to do. Oh, that's right. It's extremely difficult or impossible. Bad news about pivot tables. Extremely difficult or impossible to make a graph from it. So what I do is I copy this, and I have to create some labels here. Plot, basal area, excuse me, and then biomass. And now I can just kind of explore the data and say, okay, how well are these things related? Well, they should be closely related because biomass is based on our biomass equation is based on diameter, and so is excuse me, basal area. But be that as it may, you know, what you end up here with is a pretty strong linear relationship between basal area and biomass. That's expected. There's some deviation from this, and it's kind of curious why that might happen. But regardless, there it is. Okay, I've got this stuff. I now have the total amount. I can calculate the total biomass per hectare or expected biomass per hectare or basal area for Poly Canyon. I can calculate the, all kinds of things from this. Here's another nice thing you can do if you wanted to say know the variance of one of these parameters. You can actually put it in here. In this dialog box, you can right-click on these and you can change whatever calculation it's doing. So it's summed across an index here, and the index in this case is plot. But let's say that we want to know the standard deviation. Standard deviation of basal area within a plot. Well, we can do that. We can just calculate it right like that. Creates another column, and now you got the standard deviation of basal area right there in the same dialog. So you got the sum of the basal area and its standard deviation. Again, these are not in basal area per hectare, so you need to multiply by 20 here to get that. But there it is. This is pretty nice. I mean, I can do the same thing for biomass. Let's, like I say, just demonstrate this again. Go in here and get the standard deviation and it tacks it on there. All right. So I don't want to overwrite these things that I've created. If they have value, I don't know how much this thing has value, but I don't want to lose it. So one of the things you can do is create multiple pivot tables, and what will happen is this will overwrite everything that's underneath it if I make it really long. But problem that we have is that oftentimes we're not necessarily solely interested in something characteristic like basal area we're interested in our full data set, but we're also interested in how it breaks down by species. So what I'm going to do in order to figure that out is to insert a new pivot table. And again, I'm going to put in the existing worksheet. I'm going to just put it over here so that I can make a big mess, essentially. And what I've got here is, I need to know more than just what the values are by, oftentimes by plot. I need to know by species. So I'm going to put species in the top column. There's an error in the data set, which is this blank thing. There's some data that still needs to be entered. And I can put basal area in here. And again, I'm summing it by plot. You can get the standard deviation the same way, just by updating it. Now, one of the problems that you get with Excel is it's not going to fill in zeros for you. And those are actual zeros. In this case, the absence of eucalyptus in all but one of our plots means that there is not eucalyptus in those plots. I trust you. I think that you made this, collected this data correctly. It's not surprising to me that there would be one plot with eucalyptus because I contrived to have a plot with eucalyptus in it, and you can see that it has a lot of basal area, and it's one that has a lot of biomass. Maybe it's right. Whether you like eucalyptus or not, it certainly has a lot of biomass. Okay, so this is doing this kind of thing. And if you recall, there's one other thing here, and this is the size class, which we might want to summarize size class here. And so let's try to do that. I'm going to insert a third pivot table. Again, existing worksheet. Just cruise over here. Like I say, I'm going to just make a big mess. That's fine. What we want to do with when we categorize size classes, we want to count by size class. And one of the problems here is we want to count how many individuals are within each of these size classes. So what we end up having to do is index the data by the thing that we are that we're actually trying to count. So what I've got here is I've got size class counting the values for each individual size class. So that's kind of confusing, but we can start to make sense of it as we look at this. So for size class 2, I've got a count of 3. For size class 3, I've got a count of 1. 10, I only had 1 in there. 11 had 7, so that was the trees that were larger than 100 centimeters. Fair number of those, lots in the smallest size class. And then there are a few errors here. As you can see, it's counting the second size class twice. And I don't know why it's doing that. It's having some problem with the indexing. It's not equating all 2's equally. And that is something that you can fix just by adding these things together after the fact. But before we do that, let's put species in here. Because you might want to know both, you do want to know both how your species break down in terms of their size class distribution, as well as how many are in each size class. So here's what I've got. It's pretty messy, and what I'm going to do is I'm going to get it out of this, get it out of the pivot table so I can actually work with the data, and I just make a copy of the data to do that. And then the thing that I've got to do, I'm sorry for kind of bouncing around here, is I need to also copy these labels. And you always want to be careful here. I can see potential problems. Oh, what's wrong with you, Excel? Would you just please copy? There it is. And then I've got size class here. And I knew there was some problem. What's happening is it's treating some of these as text, as a categorical variable, and some of them as continuous. I'm not sure why that is. But what I'm going to do to try to get around it is I'm going to try to sort it based on size class. I'm going to see what it gives me. Okay, good. Sometimes Excel has your back. So sort anything that looks like a number as a number, or sort numbers and numbers stored as text separately. I'm going to tell it to sort everything that looks like a number as a number. And the reason I'm going to do that is because it helps me clean up this data. It's got this one header millis that needs to be in the second size class. So I'm just going to update that, turn that into a 9. This is do the same thing for this one errant Coast Live Oak and this one errant Bay Laurel, and then I'll even update the total. And then I can do that for this one as well. There's only one in this size class 3. And here's why I do that. Oh, excuse me. I better do it for this one too. That has 2, and as you can, oh, excuse me, that's not right. This is where things get dangerous here because you forget everything you did, and I'm pretty sure that I have a mistake right here. But I'm going to just go with it because what I'm trying to do here is just give you an idea how to do this efficiently. So I've got that. Probably the best thing to do is to actually fix the data. It's always better to fix the data, especially if you needed to say get a breakdown by plot or something like that. But I've got these size classes here. I'm going to pretend like this one doesn't exist. And what this is going to allow me to do is create some illustrations of how these stands look. So I'm going to actually put in a bar chart here. What I've got is, again, it's giving me some trouble. I'm going to make this. You can change how Excel is treating some things by going into this formatting cells. I'm going to tell it that this is a number, and then I'm going to delete this whole chart. I'm going to try again, see if it does this correctly. Actually, you know what? I'm going to do this. I'm going to go in and format cells, and I'm going to make sure that they are all numbers. Okay, hopefully that will work. And I'm going to try to make a new illustration of my stands. So it's kind of weird. It's putting size class in there as its own thing. I'm just going to delete that. But here's the size class distribution for eucalyptus. in our Polycanyon data set. Essentially, there's some small ones, but then there's just some really big ones. And that makes sense because eucalyptus is mainly even-age stand. I think eucalyptus is not really that interesting here. This one is probably going to be more interesting. That's the coast live oak. And I can just insert this graph here. And this one looks a lot more interesting. There are some big coast live oak, and there's a very even distribution of them. There aren't as many small trees with coast live oak, which is maybe a problem. If there isn't enough regeneration, then after a disturbance, we might not be able to quickly reestablish canopy species, and that could be problematic. I think it's pretty interesting, though. Overall, it's not too surprising. Most of the stems are small, under 20 centimeters or under 30 centimeters, and there's probably, we should think more about this. It's looks pretty good, actually. I would expect a little bit more of these in these smaller size classes, and maybe something like fire, some prescribed fire would help make these more sustainable in Polycanyon. So anyway, that's that. The last thing that would need to be done here is we have these category labels, but they don't mean anything as they are written. And of course, the category labels do mean something. This is everything that's under 10 centimeters. This is everything that's under over 100 centimeters. That has actual meaning beyond the number 1 and 11. So reporting this result requires that you need to make these figures clear.